Okay, so good morning, good afternoon, good evening. Welcome everyone to the February 2021 monthly webinar series from Phase 1. Our today's webinar is related to using drones and AI for high throughput phenotyping in experimental fields. Let me introduce your today's presenters. My name is Carsten Wieser. I'm Integrator Sales Manager for Phase 1 for EMEA region, and I'm based in Cologne in Germany. Joining me today is Sam Oswald from VITO in Belgium. Sam is R&D data scientist at VITO and will give us detailed insights into what is possible by using high-resolution drone imagery with AI in VITO's MAPEO software. Welcome, Sam.
Thank you.
So I will start with a very few corporate slides and will then hand over the presentation to Sam. When this is finished, we have some time for question and answers for today's webinar topic. So if there's any question that you have during this webinar presentation, you can type in a message in the question chat box of the GoToWebinar app. And my colleague Tina then will take care of those questions. And at the end, she will share it to all of us. And Sam and myself will try to answer them directly. So let's start with some very few corporate slides now. So Phase 1 is a world-leading provider of digital medium format imaging solution, founded 1993 in Denmark, and we provide ultra-high resolution cameras and highly productive software solutions. We operate several sales and support centers for Phase 1 across the globe. In Denver, it's in Colorado for the Americas region. In Cologne, we have the office for the EMEA region and Australia, and in Hong Kong for Asia and South Pacific regions. Our company headquarters is based in Copenhagen in Denmark, and there's also our main R&D center located. Further R&D and production centers we have in Japan and in Israel. In addition, we have more than 50 plus distribution partners, which offers a global network of sales and support centers, which makes us a fully customer-centric organization with 24/7 customer support. So we serve the world's leading brands with top image quality and productivity in various applications. So let me give you a little view also to the Phase 1 camera lineup. So we see here the actual lineup of Phase 1 aerial cameras. It starts with the IXM camera, which is available with 50 and 100 megapixel, which is mainly designed to be small and lightweight for drones. We have the IXM RS, which is 100 or 150 megapixel. And we have two large format camera systems with 190 and 280 megapixels. The applications where you can use these cameras is very wide range of applications. So all kinds of drones and UAVs. The IXM camera fits perfectly into it, but it's also used in smaller multi-camera arrays for airborne manned aircraft applications, and it's also very common used in inspection applications in different kinds of aerial platforms. The IXM RS camera is mainly the one that's slightly bigger, but also slightly higher resolution. And these are mainly dedicated for manned aircrafts, for systems, Phase 1 aerial systems, and also multi-camera systems from our partners. But it's also very common to use next to LiDAR, airborne LiDAR systems, and as well also in many inspection applications. So to give you a little overview about what applications the cameras are often used to, for the UAV and unmanned area, it's all kinds of inspection, road and bridge inspection, pipeline inspection, rail track inspection, wind turbine, power line, but also more and more used in the agriculture and phenotyping field, which we get an outlook today, but also for high accurate mapping and GIS applications. The bigger cameras then from the manned aircrafts also for mapping, photogrammetry, all kinds of agriculture, forestry applications, oblique imagery, city models next to LiDAR, as I said before, and also for inspection. The camera we use on drones is our IXM camera. It's available with 50 and 100 megapixel, and it's very small and lightweight. It's just 1.1 kilogram, like it's shown here on the slide, and it's very fast, 3 frames per second capture rate, wide dynamic range, so you can also capture images when the light is not as good. And it's a reliable workhorse with a minimum of 500,000 shutter activations before maintenance is needed. And it really gives you on day-to-day operations what you need. To give you some example here, this is of the application where the topic is today. So you see here that with a high-resolution camera, you can still cover a large field of view. So this is an example from 1 millimeter resolution per pixel, and we have still a very view per image from 12 by 9 meter on the ground, and we fly also even at a millimeter very high, 21 meters. Here another example, 6 millimeter resolution. You already climb to 56 meters altitude and get a lot larger coverage from 70 to 53 meters, and still have the 6 millimeter resolution if wanted. To show the high resolution compared to other cameras, you can also see here that the coverage is a nice thing. So you can fly higher altitude, cover more scene, but still maintain the same GSD, or sorry, same detail level as you see here. Less resolution on the left, smaller field of view, and more on the right. Even when the field of view is, and you compare on the pixel level, on the resolution level, you see that the nice lenses and the large medium format sensor we are using, even on the same resolution class, shows more details, more crisp and sharp imagery, which you also can see here in these examples. But now let's hand over the presentation to Sam, who will give you an insight to VITO's MAPEO software. Hello, Sam.
All right, thank you, Carsten. So as he mentioned earlier, my name is Samuel Oswald. I'm a research data scientist at VITO, specifically working in the remote sensing department. And just to overview who VITO is, we're a European research company working in a wide variety of domains. So in addition to remote sensing, there's health domains, materials domains, environmental modeling, as well as others. And we work with a lot of industrial and research partners on a variety of projects. So within the remote sensing team, there's around 100 of us, and we work on a lot of different remote sensing applications, from satellite imagery looking at kind of global and regional trends, and then towards airborne and unmanned aerial vehicle imagery, which can focus on precision agriculture and also on the phenotyping case. And today we'll be focusing on this phenotyping case, which is what we try to address with MAPEO. So for those who might be unaware, phenotyping looks at the study of plant and environmental interactions. And so specifically we'll try and analyze how we can quantify different plant traits and how they may react to different environmental or other stimulus, or to compare varieties, for example. And there's different ways of doing this. So it's common to do it in a laboratory setting where it's possible to really get a lot of fine control over the plants and have a large number of cultivars for a short area. However, this also is less relevant to what the ultimate agricultural conditions will be. So in a lab, you might not have as many unpredictable weather or environmental impacts occurring. And so in the field, whilst you aren't able to have as many breeding lines, it is possible to perform trials that are going to be more relevant to the final production or operational context. And so just to kind of also give an example of what phenotyping is versus precision agriculture, phenotyping really looks at trying to quantify the different plant traits and the functional and structural properties of plants, whereas precision agriculture focuses more on generating actionable insights in already established fields. So maybe how much nitrogen needs to be applied in an area based on drone measurements or some other input action. And for phenotyping in the field, it's traditionally been done with an expert, or rather a team of experts, which could include a trial manager, a seed breeder, a biologist, and numerous other roles. And this is often quite a time-consuming task when doing it with manual surveying, as you might see here. It's difficult then to scale that to very large trials, and there's also a risk of subjective measurements. So with a drone, we believe that we can overcome these difficulties. You very quickly get a bird's eye view of the canopy, and then you can later use that data to process any number of different traits or indices indicating different traits. And what we're looking at is which traits and which crops can be covered, which technologies and skills do you need to perform this drone analysis, and also how can we incorporate it into an operational workflow and make it scalable. And so we've, by working with a number of partners, found many applications for this UAV phenotyping or drone phenotyping. One such one is plant height. This is a sample case for wheat. So plant height can have a lot of different uses, including for kind of measuring the overall health of a crop. It can be an indicator of yield. And in this case here, you can also see it's an indicator of when you might have lodging, so plants falling over and becoming unusable. And we've already found that these products are quite well correlated with ground measurements. So there's certainly confidence in the digital elevation models that are produced in these cases, which form the basis for these heights. Other applications can look more at spectral indices. So in this case, we were looking at strawberry disease detection on another trial field. So in addition to capturing a basic red, green, blue imagery, we also have used multispectral cameras to calculate indices such as NDVI, which can be a general measure of plant health. And through this, it's possible to then see which areas might have lower NDVI and how that might correlate to disease presence, and compare that across numerous varieties or across numerous sample plots, as is the case here. Another application is for capturing crop cover. So this is another wheat example looking at early growth rate. And this is calculated using a model which can separate background soil and vegetation. So that is useful for calculating how fast different varieties or different test plots might grow, or for finding the time when plant emergence actually occurs, which might have implications for the later growing season. More recently, as there's been developments in drone technology as well as in the machine learning theory and computational power, it's become more and more important to be able to use object detection and other advanced artificial intelligence models in your workflows. And this is something that we've aimed to incorporate across a variety of our crops as well. And there's quite a lot of applications for this. So one application is in flower counting or plant organ counting. Here's a sample case for onions where you can see the flower count, and this might be an indicator in this case of regions of low seed quantity, or it might be an indicator of when you can find the optimal harvest time. And of course, having just these bounding boxes or the dots on a field isn't so useful. So we've also made it possible through a platform, which I'll introduce later, to generate statistics showing the mean object counts or the total object counts across your different trials or throughout the field. Another object detection application could be for plant emergence, so similar to the use case before, but trying to identify very specifically where you have this plant emerging and kind of removing the presence of background weeds. So here we've also seen good results, and it functions similarly where you might calculate areas, as you can see in the bottom right, where there's a lot of plant emergence occurring, and also contrast that with areas where you're seeing low plant emergence at a certain date, which might have implications for the trial results. And so this is all very useful, and we've been looking a lot into how we can kind of apply this and how we can make it very easy to use and very easy to scale. So in 2019, we performed a wheat head detection test looking at different flight heights and resolutions, as well as various cameras. And our main finding was that, of course, as you might expect, the camera does affect the quality and the resolution will affect coverage. So here on the first line on the left here, you can see 3 separate cameras going from a fairly high grade to a consumer grade camera. And despite in this case showing the same ground resolution, indicating that it should be possible to have very similar images and very similar object detection, you can see that the one on the left has a lot more detail, better contrast compared to the one on the right, which, despite being the same resolution, even looks a bit blurry. On the bottom row, you can see how the resolution will change the object detection possibilities. So on the left, you see the highest resolution at 1 millimeter, which shows quite well-defined objects. However, as you move along, they start becoming blurrier. The pixels also start becoming smaller, which will make it generally more harder for an object detection algorithm to run. And when performing these flights, whilst it would be ideal to simply get this lower resolution, with a lot of cameras, this isn't so easy, as when you want to get this high resolution, you have to fly then very, very close to the ground. And this can have a lot of effects. On the right, you can see how this has affected the alignment, as when you create an overview of a field, you will align all of the images together. It looks for common features between the images. And if you have an image that looks at a very, very small part of the ground, it might be hard to find these kind of common features. And you can see the red overlay indicates this was the total area that was able to be covered by the 1 millimeter flights when aligning them. The yellow indicates the total with the 2 millimeter flights, and the large RGB background shows full alignment with the 5 millimeter flights. However, the 5 millimeter flights, of course, are unable to be used for object detection. And so this prompted us to look more towards cameras which might be able to satisfy the needs for both high resolution and high spatial coverage. And of course, this led us to the phase 1. And this overcomes a lot of the common data issues for very high resolutions. So it flies high enough that it won't affect the fields, as another impact when flying low is that the rotors of the drones might actually start blowing onto the trail, potentially affecting it. It covers a larger spatial extent, which will create easier image alignment. You can see here a comparison of what you might expect with a 20 megapixel camera, which only covers a small area relative compared to the phase 1 camera. And this will result in less features being able to be detected for alignment, which isn't an issue, of course, with the phase 1, which has a lot of features readily visible. Another advantage is faster completion of flights, since as you fly throughout the day, if you're flying especially a larger field, you will have potential issues with changing environmental conditions and changing light, which is something that you generally do want to avoid when performing these missions. And so, as you can see, the detail, which I've also talked about, is very, very crisp. The contrast is very nice. It's not over or underexposed in any way. You can see a lot of internal geometry in the objects, which for an object detection model will make it very easy to distinguish between, say, this wheat ear and this leaf. And of course, as I've just mentioned, it covers a lot of areas, so you can see the kind of non-moving and more static parts of the field, which can be very useful for alignment. And here's just an example of what we've been able to do so far with wheat head detection and how we can display it in our viewer. It's very easy to visualize, to zoom in. You can move across it, and the results so far are very good. We are working on further improvements for some of the more edge cases. However, they, for the most part, capture all of the wheat heads. And whilst there's some underestimation, there's no overestimation that we have found so far. So overall, it's very good already, and we expect to further improve it in the future. We're also working on features so that users can help improve their own annotations. As you can see here, one such feature involves actually selecting the wheat heads which weren't covered in an initial model, and in this way refining it over time by adding these additional annotations. And so that was an overview of the things you can do with UAV imagery. And for that, what we want to do is make it possible to use UAV imagery in a very scalable and easy way. And so for that, we've designed MAPEO, which is a high throughput end-to-end operational drone image processing system. And we designed it with a number of requirements in mind, including that we want to have consistent data over growing seasons, years, and locations. It should be, for the most part, automated, which can reduce cost and increase the speed between ordering a flight, completing a flight, and having the data readily available to use. Of course, it should be easy to use, and it should be reliable and based on proven scientific research. And as I mentioned, it is an end-to-end drone-based phenotyping platform. And so there's steps all the way from flying through to the upload of data, checking, processing, visualization, and then further analysis, exporting into other workflows, and improving and iterating on the processes. So I'll overview how these different processes work, especially for the user. We begin with an ordering system. So this is where you create the initial step for actually flying. And in most cases, this will first involve creating a new field if it's the first time you'll be flying in this area. And so we've created a tool that's very easy to use satellite imagery to search wherever you want in the world to find your field, and then create a simple polygon outline and define it as the field that you'd like to fly in the future. From here, you can order flights for this field. So this also is quite simple. You select your field, you select your crop type, and we have a wide variety that you can choose from and are always able to include more. And then you can also choose which products you would like to include. So you might also want to include different dates for your flights. So you might have one date where you establish a baseline, which might include an RGB flight and then an elevation model creation. And then later flights might look at, say, changing plant height or other different statistics. And there's options to create all of these flights at once and really kind of define what products you want to collect from this order. And we're also versatile here to flying with lots of different types of hardware. So it's an agnostic platform for different drones, different cameras. We do also incorporate GPS and GCPs so that you can really align your images and your operations and campaigns over time, and a flight app to make it easier to perform. And so for the flight itself, this can be done in two ways. It can be outsourced. So we work chiefly with a partner called Sitemark, who provide a worldwide network of drone operators. They have one procedure for all locations, so you can have a real kind of standardized training for your pilots. And even if you have disparate fields across the world, you can trust that the results are going to be reliable. And they additionally provide operational support for you and for these pilots. But the other option is, of course, to fly yourself if you have your own drone or some such. In that case, we can provide consultancy on drone operations. And we also provide a field software tool for data quality checking. So the field software tool will check that you've actually satisfied your flight parameters, since it's best to avoid any potential issues that might pop up during the flight, since afterwards it could be difficult to rectify them. However, through this software tool, it's possible to check things like that the height was satisfied, the entire area was satisfied, there's no lighting issues or issues with the drone being flown around or kind of distorted due to wind. and then you can be confident that the upload will include good data. From here, it's ingested into our systems once uploaded, and based on the input you performed at the ordering, an automated workflow will occur, which will divide the data into various processes. So generally there'll be some base products produced, which will be your orthomosaics of the whole area, as well as elevation models. And then depending on what you've listed as the products you'd like, these further products will also be processed. And for the most part, this is very automated. There is a manual step for GCP selection to ensure that all flights are aligned. And throughout the process, there is a dashboard that quality engineers can work with in order to troubleshoot any issues very simply and ensure that the data is still delivered promptly. And so there's a lot of different derivative products that can be calculated. These can include things which are quite simple, like NDVI or the crop cover I've shown earlier, or the plant height. However, we can also incorporate kind of new, more cutting edge workflows. One such one is the object detection workflow, which I've also mentioned. And so this involves creating a strong model database, which is able to manage a lot of input of new data, and over time leverage this data to create stronger models. And so how this works is that if you want to classify a wheat field, for example, in addition, rather than simply having your wheat field be annotated and then have the model perform solely on it, it will also utilize previously classified wheat data or annotated wheat data and combine all of this data to create stronger, more general models, which are able to better capture edge cases and, as time goes by, require less data input. And a kind of issue with previous attempts to do this in non-standardized ways has been that it's been difficult to aggregate this data due to, say, flights being different or collection standards being different. However, with our workflow, which ensures a standardized collection of flights, it's possible to overcome these issues and have an object detector that really detects the differences in the objects rather than, say, the differences in the images, which is an error that can be introduced otherwise. And there's also optimization towards phenotyping applications. So this includes really customizing the surrounding model architecture and implementation in order to focus on the typical phenotyping cases, which are often small pixel-wise objects and often densely packed objects. And smart training data selection. So for example, in the case of using drone imagery, you may only want to use training data from the central part of the image and exclude training data from the edges, where you will typically have objects shown at oblique angles rather than head on. And of course, we also make annotation easy. So we partner with Robovision, who is a platform that allows for a lot of machine learning applications. And one of these is annotation. And through this platform, it's possible to easily enlist remote annotation teams who we've worked with before and are specifically trained for these kind of tasks. The annotations will then be output in a consistent format. And so the movement between having this data submitted and having the models run and inference performed is also shortened. And there's an accessible UI with useful features, and it's web-based, so it's accessible for the user should they wish to establish a gold standard or ensure that the annotations are going correctly. And following the processing, of course, an important part of the data is that it's actually usable. And this starts with a quick overview and visual inspection of the data. And so through our web platform at MAPEO, you can visualize all of the products for a site over different dates, compare them, and then generate statistics. And it's possible to, of course, look at different adjustments to how you want to display the data. For example, if you really want to see a fine granular distance in a spectral indice, it's possible to do that. And following this, there will likely be further analysis that you'd like to do on your data. So this will probably involve an export of some of the data, most likely in terms of exporting different plots, which might contain your different trials. And there's a lot of ways you can approach this. So here we can show that you might want to upload your own field layout that you've already prepared, which is accurate to the site. Or if you don't have that, it's possible to create a field layout with our tool. And here's a kind of demonstration of this tool in action, sped up a bit, but it's very easy to create a bounding box over your entire field and then establish how many rows and how many columns are in this field, and then the buffers between them so you know the exact rectangle that you might want to look at the different indices and statistics in, and then from there export that. And here's a kind of depiction of how the extraction can be simply done, either as a CSV or as a shapefile, by selecting the products you would like to export, the dates you would like to export, and then from there putting in your email and having it delivered promptly. And just like that. But in addition to extracting using this tool, it might be that you want to have it more autonomously exported into your own workflows. And so the data is, of course, stored also in a standardized way so that you can expect different raster products to be stored in a similar manner, and for different vector products to also be stored similarly. And there it's then easy to import all of these into, say, your own notebooks or further scripts which have your own specific analysis and perform the custom data analytics there. Or of course to export them also into other existing workflows as an additional data source. And so to conclude, there was kind of 5 key things that I would like to just kind of nail in. So drones allow for a quick and reliable traits to be collected for various phenotyping applications. Image resolution and quality is key for successful AI algorithm development and application. Using the phase 1 IXM 100, in our case, allowed us to collect this very high resolution data and have it be reliable for actually aligning and having good spatial coverage. Advanced modeling can be incorporated and scaled, generating powerful insights. And finally, MAPEO is our solution, which is end-to-end, allowing you to use your own or outsource drone data acquisition to process analytics on your phenotyping fields. So thank you.
Yeah, thank you, Sam, very much for all these insights and the detailed review of your software and also tools. We now have time for some question and answers, and I hope you all typed in some of the questions during the webinar. Maybe we ask Tina, do you have received some questions for the topic?
Yes, we do have some questions, and let me please start with the first one. Questions like...
I have an echo hearing you, sorry.
I also heard it.
Let me try again. Is that better?
No change.
Okay. But the first question is, will this also work with creating fruits and flowers, for example, for strawberries?
Sorry?
It is hard to understand.
Could you repeat once more, Tina?
Yes, let me repeat that. So the question was like will this also work for counting fruits of flowers, for example, strawberries?
Yeah, that's something that I have done in the past year as well with good results, specifically for counting the strawberry flowers at an early stage. And yeah, it was very much possible. We got very good results. You're welcome to email me and I can possibly share some details. But for sure, we found it possible, as in this case, with the flowers, they're generally quite well contrasted with the kind of background vegetation. So with the green of the plant itself, making it possible to do so. And as I mentioned, architectures are really customized towards looking at the typical use cases in phenotyping, which is small pixel-wise objects, which is often the case with strawberry flowers. And yeah, the results we got were quite good for them.
Okay, thank you, Sam. Hopefully quality is better now.
No, it's the same. Maybe you type the questions to me, and
Yeah,
then
it might be best to type.
I will.
Yeah, please.
Yeah, maybe I can step in here. Do you hear me?
Yeah.
Well, okay. I was also following the list of questions. One of the questions we have here is in vegetable breeding, the trial fields are not so uniform as in wheat, for example. Are you working on a tool for generating more irregular trial fields? That's a question for Sam, I think.
Yeah. So with our current tool, it's possible to define multiple polygons. So you don't need to, for example, work solely with one square and one kind of delineation. And then it is also possible for us to work with any kind of irregular fields to kind of really get the kind of well-shaped differences which you might find in vegetable or other application fields.
Okay. Maybe a question for Carsten. What is the most aperture that is used for these photos? The most used aperture value probably. What are the settings which you would recommend for such a job? Yes.
So we optimize our lenses always that they work already best with open aperture. And in this case, for the range of lenses for the IXM camera, they all start at f5.6. But this open aperture for this lens already can be used and delivers a very homogenic image quality across the field of view.
Okay. One question for Sam. We are a research institute. How can we collaborate with you guys?
Yeah. It's very possible to collaborate. We work a lot with other research institutes and are interested in project partnership. We, of course, are especially interested in taking the lead in terms of data collection or data processing. And depending on what you're working in, we're also very interested to work with various application experts. So I think to get it started, it's possible to email myself and I can provide you with further details or get you in contact with some of the other members of the team and see what possibilities there are for research partnerships.
Okay. There's another question. Can you also measure the height of the products?
The height of the product. So I suppose in that case, it would be the case that the height is a product itself. So for other products, it's often just a derivative of that. If you mean for the object detection height, it is also then possible to measure the height of the objects based on calculating where the bounding box occurs and the height calculated through our height product also at that same spot, and then you can get a height product. Although this is something that is possibly not fully implemented yet, so it might not be, there would have to be some kind of working out of the kind of point where the object and the height are the most equal. So if you wanted to get an entire object height, for example, for a wheat organ, then it would be more difficult to calculate it from the base of the wheat head to the top rather than just a kind of average height at that point.
Okay. Next question I see here on the list. Is the quality check part of the MAPEO or is it a separate tool?
The quality check is part of MAPEO. So there's kind of two quality checks. The first initial quality check will occur in the field through our upload tool, which we provide, and this upload tool contains meta information derived from the flight ordering, which will define what is considered acceptable quality. And if that is approved, then it will be uploaded. And in the processing, there is also automated quality checks throughout. In the case that there is an issue, there will be feedback provided about what that issue is to the quality engineers.
Okay, looking at other questions. Okay, I have a question. Is it possible to use MAPEO or drone technology in general on irregular fields, for example, in fields with diverse topology or with the surrounding forest? And what would be the downside?
Mm-hmm. Yes, certainly. It's possible to use it. In areas with surrounding forest or other features such as houses or infrastructure, that's usually not such an issue, depending on how kind of overlapping they are. So if the only kind of issue might be in terms of flight height in some cases, however, if you can clear that, then it should be possible to use. For irregular topography, it's also possible. The issue there is that it does need to be made clear that the topography is irregular, as there will likely be some issue, or there can be issues relating to a consistent flight height. So it might be that the drone is programmed to fly at a single height, whereas on a field with irregular topography, it would be ideal to fly it at, say, different structures of height. However, things like the actual planned height, which are calculated, or the digital elevation models would still work fine in this case, as using the kind of image alignment, it's actually able to calculate the 3D topography of the area.
Okay, Carsten, you may want to add something to that, because I think you also with phase one, you are in maybe not in agriculture, but in other cases where you have challenging topographies. Are there certain additional remarks that you want to state?
So we are, from the camera perspective, we are very flexible in terms of as we deliver a wide range of lenses, and then you can fly different altitudes to maintain the same resolution with choosing different lenses. Yeah. So like this, I think you should overcome that. Yeah.
Okay, I have a couple of more questions here coming in. Is the quality check part of MAPEO or is it a separate tool? Or did we already have this one?
Yeah, I think that was already
this.
covered.
Yeah. Mm.
That was already done. I have here a very small screen to look at the questions.
Thanks for helping out here, Dries.
Yeah,
much appreciated. Yeah.
No problem, no problem. Hi, Sam. Would the MAPEO be applicable in smallholder farming settings where mixed cropping is dominant?
Yeah, certainly. We have worked on mixed cropping fields before, and it also is applicable there. The actual platform itself is agnostic somewhat to different crops, so it can work on just about any agricultural field. For a mixed crop field, for things like object detection, this obviously would be a bit different, as you might be, instead of classifying a single class, classifying multiple classes. However, we are also capable of doing that. And for a lot of other products, including plant height or vegetation indices, these are calculated independent of what the crop actually is.
Okay. Thanks for the answer, Sam. What about fruit crops such as apple? Is it possible to implement this technology in these plantations where top views are not enough? Thanks again.
It's for applications in orchards where you might have side views, this is something that would be indeed more difficult with just a top-down view. So in the apple case or in fruit cases, it is possible then to get some insights from top-down views, including your general plant health indicators such as NDVI. And where you might have the fruits themselves obscured, it would be useful to do a side view. However, at VITO, we also do have other projects looking at fruit orchards. So depending on what kind of products you're actually looking for, it might be possible to form a partnership or to work together.
Yeah. Another question, can MAPEO use imagery from other cameras other than phase 1?
Yeah, it's possible. As I've mentioned, it is also camera agnostic, so we also work with multispectral cameras. In addition, it's able to use thermal cameras, which we work with as well, and hyperspectral cameras, although this hasn't been done as it hasn't been operationally feasible as such. Other cameras can be worked with. As I mentioned, phase 1 is preferred, especially in my experience, for these very, very high resolution tasks, such as the object detection. And then for other cameras, it's also possible for, particularly for multispectral flights and calculating NDVI, we work with several cameras.
Sam already explained the phase 1 camera can bring you benefit when you do object detection on the detail level. So the details are much higher. Also, the homogeneity of the image is more equal. So the center of the image is as good as the corners and the other way around. And also it helps you to scale the operation. So one image covers a lot bigger area. That also means you reduce the flight time and the needs for flying overall.
Yeah, indeed.
And also
it's very...
have higher altitude where you can do the same resolution, which also not brings you the downforce from the rotors, from the wind, the drone, which also not influence the images anymore.
Indeed.
Okay. One last question, I think, for Carsten. Don't you have a phase 1 multispectral model for UAV? Multispectral data can be more meaningful even with lower resolution.
We indeed have, I would say, what we call the 4-band kit, but it's then a second camera, which needs to be installed on a bigger platform of drone. But this is possible, and then we also can do NDVI images out of this. But the multispectral cameras with more than 4 bands, we not offer yet. No.
Okay,
drones, I would say. Yeah.
I think we are there. Unless Tina, you see some more questions. I have a very small screen, so.
I think we're all good. Yep.
Your echo is gone.
Yes. So yes, Dries, once more, very much thank you for helping out here. Much appreciated. And looks like that Tina has got rid of the echo. So thank you. Yeah, I think when there's no more questions, we will closing now the webinar. And so thank you for all the viewers for joining this webinar series. Looking forward to see you again at the next webinar. Like always, the webinar is recorded and will be provided here within the next 2 or 3 days on our website. So you can go back and view it again or reference it to someone you also would like to see that. Thanks again for joining our webinar, and yeah, have yourself all a wonderful and great day. See you next time.
Yeah, thank you.
Thank you, Sam, again. And
yeah, thank you to phase 1 for hosting us, and yeah, it was very nice.
Okay, so
all right,
see you next time. Thanks to all that were involved to this webinar.
All right, bye.
Bye.